from the University of Arizona in Tucson, Arizona. I am a senior undergraduate over there. For my project, it is called Paper-Based Organ Chip for Herbal Medicine Toxicity Screening. So if you don't know that herbal medicine are plant-based alternative medicine used for basically maintaining one's health. And a lot of people believe that it's a great alternative medicine because it's healthier and basically a good, sorry, I'm so bad at this.
Yeah. Start again?
Yeah, please.
Okay,
I'm just really nervous about this, yeah.
Don't worry, I can start 10 times.
Oh, okay, okay.
So I'll do it again.
Okay. Hello, my name is Jennifer Ngo. I am a senior undergraduate at the University of Arizona in Tucson, Arizona. My project is called Paper-Based Organ Chip for Herbal Medicine Toxicity Screening. Alright. And so my project is basically testing herbal medicine. A lot of people believe that pharmaceutical medicine are pretty dangerous because if you have a high dosage, then it'll lead you to overdose. And so people believe that herbal medicines are good alternative plant-based medicine because they're natural and healthier. What they don't know is that there are some cases that the patients could have a severe jaundice or a acute hepatitis as well. It can also be severe enough to have a liver transplant. So that's why I want to focus on herbal medicine and then basically raise awareness of their toxicity level. So what I use for an engineering application is a paper organ on a chip. And decades ago, they've been using a organ on a chip with PDMS chip or polydimethylsiloxane. And the problem with that technique is because it takes a few hours to fabricate, which is a very inconvenient time set. So instead, we use paper organ on a chip to basically lower that fabrication time by just using a wax printer. And then, so what we should see is that the black part of it is the wax barrier or the hydrophobic barrier, and then we create a microfluidic channel. So cells will be basically cultured throughout these channels, and then we'll induce drugs in the inlet and then collect the supernatant on the outlet. So the paper that we're using is not a regular copy printer paper. It's basically a nitrocellulose paper because we've been testing it and then we see that the cells are very adhesive to that type of paper. But for my project, we were working on the static condition or no flow applied to the cells. And then so we use tissue culture plate as one of our testing, and then as well as nitrocellulose paper. Like I said, that's one of our main goals. And so what we tested was control, Gamira, Japero, green tea, kava kava. And then so these are all capsule. They're not tea or anything like that because they have a higher concentration. And then so our concentration are based on the correlated recommended dosage from the bottle, and then we proportionalize it to how the cell should intake it. So what we see in our cell images is that kava kava, Gamira have a higher toxicity level because you can see that these are very random morphology and there's not a lot of confluency. So and the cells that we use is red vascular endothelial cells because the endothelial cells are part of the blood vessels and that's connected to the liver cells. So that's going to be also our future work, working with Hep G2 or immortalized liver cells. So going back to our image data, so we see for the nitrocellulose paper, there's not a lot of confluency changes or morphology change, and so we conclude that there's not enough exposure to the drugs to the paper, the cells. So that's why we need a flow to imply that, and then so we can see like a change of result that could possibly be to the same as the tissue culture plate. And then over here, we're looking at the supernatant analysis, which is our quantitative analysis. And then so we have the normalized cell count as well as the cytotoxicity percentage. And then so how they're related is that they have an inverse relationship. For the normalized cell count, if we have a high normalized cell count, we have a lower cytotoxicity percentage. And then, so what we can see here for the tissue culture plate, it correlates with our images. So for the normalized cell count, we have a high cell count at 0.75, and then a low toxicity for 50%. And then we see kava kava, we have a high toxicity level, and then our normalized cell count is very low. So that indicates that there's a lot of cells that are very toxic. But then you see green tea, it's low cytotoxicity but high cytotoxicity or normalized cell count. And then we see the nitrocellulose, their levels are pretty much the same for the normalized cell count. So that indicates that it also relates to the image cells. Yeah. So for our future work, like I said, we're going to work with HepG2, which are immortalized liver cells, because that's one of our main goals, since livers, organ in general, metabolize drugs. So yeah, that'll be part of our future work, and then we're also going to implicate flow to create like that biosensing technique to get an accurate data set, and then eventually replace animal testing, as well as still raising awareness of the dangers of herbal medicine. Thank you so much.
Thank you.
Yeah.